Unit 3, Day 19, Notes, Part 4. So this is a very valuable lesson that we must learn when we are introduced to the product rule. Um, so what they're saying on a previous page, the previous page, you were asked to find f prime of x. Actually, I think it was g of x. So we found g prime of x, applying the product rule to this function. So we found that, and what we did is we changed it to x to the 1/2, and we found the derivative to to be, and I think I wrote it another way also, 5/2 x to 3/2 minus 9/2 x to the 1/2 plus 1 over x to the 1/2. Okay, now what we're going to do is we're going to take this same function, f of x, and I'm going to actually rewrite it so it's x to the 1/2 times x squared minus 3x plus 2, and they're saying to first write it out in polynomial form, then find the derivative. So let's do that now. So hopefully you get this x to the 1/2 times x squared becomes x over 4 over 2. Multiplying with like bases, x times x, we add exponents, 1/2 plus 4/2 is 5/2. So hopefully you get that. Now we're going to take the derivative. And we're taking the derivative using the power rule. So this becomes 5/2 x to 3/2. This becomes 9/2 x to the 1/2, and this is going to become 1x to the negative 1. And now when I rewrite it, hopefully we see, hey, it doesn't matter whether I took the product rule or I rewrote it in polynomial form. I get the same exact thing. And now let's look below. There's something we're going to learn. I think I might have said it the other way before, but they're both going to give you the same answer. So let's figure out which way we want to do it. So if I can write the product of those two functions in polynomial form before differentiating, then the algebra is a lot less messy. So I don't know if you remember the problem. We stay away from as much as possible of rational exponents and all that good stuff. So hey, if I can multiply and do it the way we did it before, that's much easier. But they'll both give us the same answer. So let's try this next example. I have the product of three factors, and I want to find the slope of the normal line. So first, what do I have to do? Let's write it out as one polynomial. Take the derivative. That's going to give me a slope of the tangent line. Once I know the slope of the tangent line, the slope of the normal line is going to be the negative reciprocal. So let's do that. And I'll show you uh, each step. I might skip a step here. So I just took the last two factors and multiplied them together. So I got x squared plus 2x minus 3. I could use the product rule now, but I'm going to multiply it out, make it one polynomial. So I then take each and every, the two terms in the first parenthesis multiplied by each and every term in the second parenthesis, and here's my final function, original function in polynomial form. So this is going to be much easier. So a little more work up front, but now it's going to be much easier to differentiate. So there's my derivative, 6x squared plus 14x. I want to find the slope of the normal line when x equals 2. So first I have to find the slope of the tangent line. So let's find the slope of the tangent line when x equals 2. So every place we see an x, we substitute in 2, and I get 52. This is the slope of the tangent line. So for the normal line, I'm just going to take the negative reciprocal of this. And that's going to be negative 1 over 52. Okay? So do a little more work up front, multiply those out right as a polynomial, then differentiate.